right, so now we're going to go over the answers really quickly for the ones that you were supposed to do on your own. A sub 1 is equal to 729. R is equal to the negative 243 divided by 729. I do not expect you to know what that is. I don't even know what it is. Negative 243 divided by 729 gives us negative 0.3 repeating, so that's negative 1/3. If it's a decimal that's pretty and rounds, not rounds, but goes to a pretty number like 0.25 or 0.5 or 0.6, that's fine. But if it's a repeating decimal or a decimal that doesn't convert, we really need it to convert to a fraction. All right, ready to plug in? F of n is equal to 729 times negative 1/3 to the n minus 1. So f of 7, because we're plugging in, so 729 times negative 1/3 to the 7 minus 1. When you're plugging this into the calculator, you have to use parentheses on that negative 1/3. Otherwise, it is going to throw off your answer. And I got positive 1 here. Notice we talked about this a little bit on Friday if you were here. It's a positive, negative, positive. This is what we call an alternating sequence. We only have alternating geometric sequences. We do not have alternating arithmetic sequence. All right? Going to number 17, a sub 1 is equal to 6. R is equal to negative 12 divided by 6, which gives me negative 2. Plugging in, f of n is equal to 6 times negative 2 to the, sorry about that, n minus 1. Now we're going to plug in, f of 7 is equal to 6 times negative 2 to the 7 minus 1. 6 times negative 2, and then that's in parentheses, and then our exponent of 7 minus 1 gives us positive 384. Please, please, please remember that your n value is whatever term you're looking for. If I ask for the 100th term, you would be plugging in 100. If I ask for the 12th term, you would plug in 12. For all of these examples, it asks for you to plug in 7 for the 7th term. So on your Delta Math, be aware of what it's asking. The last one, a sub 1 is equal to 8. Our R value is 12 divided by 8. I'm going to reduce this fraction by dividing by 4 on both the top and the bottom, which gives me 3 over 2. If you said 1.5, that is fine as well. So f of n is equal to 8 times 3 over 2, or you can put your 1.5 there, to the n minus 1. And then we plug in, so f of 7 is equal to 8 times 3/2 to the 7 minus 1 power. Once again, make sure you're putting your r in parentheses and your exponent is 7 minus 1. That's going to give me, and this is a decimal, 91.125. Or, math bracket, you may have gotten 729 over 8. Either one of those answers is correct. Let's talk about now, just for a second, the recursive formula. So if I were to do the recursive formula on number 18, okay, so if we were to talk about recursive for a second on number 18, remember, copy what's in yellow. A sub n equals a sub n minus 1. And then we're going to say times whatever our r was. Our r, whoops, highlighted everything there. Happens in class too, right? So a sub n times whatever our r is. Our r was 3 over 2. Our a sub 1 was 8. Remember, whatever your starting term is, you have to include that with the recursive, because like we've said in class before, if Miss Reed starts with 6 and I start with 7 and we're multiplying by 2, mine's going to be 7, 14, 28. Hers is going to be 6, 12, 24. So it's very important that you include that starting value. All right, last thing we're going to do today is look at a real life application. If you want to pause it and try it yourself, that's fine as well. It says the table to the left shows a car's value for 3 years after its purchase. Write a rule to represent the car's depreciation. Anytime it asks for a rule, we're looking for explicit. The explicit one is the easiest to find, however many things we're looking at and whatever term we're looking at. All right, for explicit, you need A sub 1. A sub 1 is going to be whatever the car was the first year. So in this case, it would be $10,000. And then our R value can quickly be found by doing the second term, 8,000, divided by the first term, which is 10,000. Okay? The zeros cancel. I'm kind of trying to show you this by hand. 8 over 10 gives you 4/5. If you want to tell me it as a decimal, do the 8,000 divided by 10,000, which should give you 0.8. We know this word depreciation from the past unit. Hopefully you guys remember depreciation means exponential decay. We know this is exponential decay because our R value is less than 1. Okay, we're ready to plug in our explicit. So we have f of n equals a sub 1, which is 10,000, times 0.8, and it's going to be raised to the n minus 1. So be aware of what we're asking for. We're asking for a rule. You need to give us the explicit. If we ask for what's the value after 10 years, then you need to actually plug in and give us a number. So question 20 on this page says, what will be the value of the car after 10 years? So the 10 years is going to be our n value. So f of 10 equals 10,000 times 0.8 to the 10 minus 1. And like I said before, we're not plugging in 7 every time. We are plugging in whatever term number it's asking you to look at. So 10,000, and then in parentheses 0.8, or you could have used the 4/5, raised to the 10 minus 1 power. Okay, that's going to give me an answer of 100. See if I can get all those dots off. That's what I get for wearing a sweatshirt trying to do videos. That's going to give us an answer of 1,342.18. Remember, we're going to round 2 decimal places because we're talking about money. If you have any questions, please email me or Miss Reed, and we'll get back to you as soon as possible today. Some things that you guys need to be working on, if you have not done so, 3.4, videos and questions. The 3.4 videos and questions are going to be due tonight at midnight. Currently, we only have 5 submissions out of 32, so several of you need to get that done. The other thing that you guys can work on is 3.5 Delta Math. Remember, that's an optional assignment, but it can improve your grade. And the good part about it is 3.6 is already posted as well in Delta Math, and it's the same concept as 3.5. So if you want to get a jump start on your Delta Math optional assignments, you can. Once again, email us if you have any questions, and have a great day.